Hello, my name is Preetham Chandra. I am a final year computer science student of Adamas University. This presentation is regarding my project on refinement of digital image sharpening using transfer learning and building a GUI-based front end. So let's get started. This is the project outline I am having. I will go through each section one by one. Firstly, this is a deep learning research project. Here we are using generative adversarial networks or GAN, which was first introduced by Ian Goodfellow in his research paper back in June 2014. It is based on zero-sum game theory and is a new research hotspot. In this project, we have majorly two objectives. Firstly, we are attempting to refine the digital images we already had produced via transfer learning, and secondly, we are trying to develop a front end where a user can click on any part of a image and the zoomed version of it will be simultaneously displayed on the other side. Coming to introduction, so research in this field is important because the number of medical images available to the doctors is usually small and the acquisition of medical image annotation is an expensive process. This is the driving force of this project. In our dataset, we have a total of 1400 images which are divided into training, validation and testing images. Table 1 shows the details of dimension change that we have incorporated. Table 2 has the details of magnification of the images in dataset. Now, in this section, we have listed out few related papers published in this field in last 2 to 3 years out of many. We have listed the paper title, the name of author and their objectives. This slide contains few more papers in this field and finally 3 more papers in this field with their objectives and name of authors. Coming to the technologies used while during the span of this project. Firstly, graphical user interface. Our front end is made GUI based, that is, a user interacts easily with our application via use of menus, buttons, etc. with the help of mouse. Now, in order to build our front end, we have used PyQt5, which is a cross-platform GUI tool to develop interactive desktop websites or applications. Coming to PyTorch, which is an open source machine learning framework for deep neural network models. We have made our neural network model using SRGAN via PyTorch only. This is the proposed methodology. We are using SRGAN here, which is super resolution generative adversarial network. The motive of using this architecture is to recover finer textures from the image when we upscale it so that the quality doesn't get compromised. This is the discriminator model in our GAN. We have 3 layers, that is convolution, fully connected and max pool layer. These are the different dimensions of each layer. This is the generator model. Here also we have convolution, max pool and upscaling layer. This image shows the dimension of each of this layer in our generator model. The most important section is result and analysis. Firstly, our first objective was to refine digital image sharpening using transfer learning. So let's go through the result of it. After 20 epochs, a section of blur, generator and sharp images are shown. These are the corresponding values of magnified section of blurred generator and sharp image. We can clearly see that there is a very less difference between the RGB values of generator and sharp images. That means we can say that our model is learning good, and transfer learning using more samples is turning out to be fruitful, as we have a very less difference between generator and sharp images. Our model is thus learning. Our second objective was to build a front-end application. This is the first screen of our application. It has a button which shows load model. On clicking this button, we will get our PyTorch model incorporated within our workspace. This is the second screen, which depicts two sections actually. First is dynamic zooming and refined model, which is our feature scope. Coming to this screen, we have dynamic zooming enabled. Here a button is given which shows to browse. That is, a user can browse a 4x image into the workspace. Once the image is browsed, it will show like this. We have two radio buttons enabled. One is of 2.5x and the second is of 10x. If I click on this button, I will get a corresponding rectangle of magnification 2.5x. That is, the 4x image will be magnified to 10x once we enlarge this in the right hand side. Now this rectangle will be generated only when we click over this image. This can't be generated randomly, and this also can't be generated on whenever we click. Suppose we have clicked at this side, the rectangle can't get generated because there is this region cannot be covered under the rectangle. That is why a safe zone is being created, which is depicted by this blue um, colored region. This is the safe zone where a user can click and get a corresponding sharp version of the image. This sharp version is of this particular section, and it will get generated once we click this button. Also, we have two sub buttons here. First is standard zooming, which will be done once we click on this button, and it will be a normal sharpening. Second is a deep zoom, which will further zoom our model using the deep learning neural network model in backend. So here we have only enabled the standard zooming, that is, it will zoom our image normally. So this is all about dynamic zooming. Finally, the new research initiatives that we have, as already told, the refined models section will be developed in the near future. We will also retrain on the production of new images so that our model performs better. And finally, we will build an end-to-end application, and we can deploy it to the healthcare professionals so that their work gets better and more fruitful. This is the conclusion. uh, our model, the results of our model is shown here. Here we have a mean squared error plot between filter based sharpening and the proposed sharpening method across whole dataset. We can clearly see that our deep learning model is showing a very less mean squared error when compared to filter based sharpening. Therefore, using this technique will get minute details even to the workspace, and the cancerous cells or any cell can be detected easily without fail, which was not possible via filter based sharpening. This error shows the same. This is a plot which shows that our sharpening method is well and good. These were the references which were used. So that's it. Thank you for your time.